is your partial pressure and pressure conversions quiz. So we're going to go over it. The first one, you are very simply told that hydrogen gas is collected over water. So H2 over H2O at 22 Celsius. And we want to know what the pressure of the dry hydrogen is. I told you that the barometer reading in the lab that day was 765 torr. So this is just a simple look up and subtract, because you know that the total pressure is equal to the pressure of the hydrogen plus whatever partial water pressure has crept in there. So P total minus pH2O gives you your pressure of the hydrogen. Your total pressure reading is whatever the barometer in the lab says. So this is 765 torr, and the pressure of water, the water vapor pressure at 22 is 19.8 torr. So we get a raw answer of 745.2 torr with sig figs. So here's where an argument could be made, and if anybody wants to make the argument, what would be the argument for that being final sig figs versus 745 torr? What's the argument? No, not an argument, because the 22 is not used in a calculation. It's a lookup. Yes, but you didn't use that in your calculations. Did you use the number 22 in a calculation somewhere? Nope. It gave you a lookup for another value, and that value was used in your calculations. Who's got an argument as to why it should be 745.2 torr? If you missed sig figs on this. No, that's already 3 sig figs. Okay, nobody? I was giving you a chance to redeem yourself if you were a person who missed your bonus for sig figs. Because this is addition and subtraction. Oh wait, no, you know what? Never mind. Either way. Never mind. Cut and dry, 745. I was thinking for a second. Because in addition and subtraction, the rule is what? Places behind the decimal. Least places behind the decimal, so that would still be this. So you'd still have 745. And if we go with the 3 sig figs, then it's 745. Okay, number 2. Number 2 required you to do 2 things. You had to understand combined pressures to get the pressure of the dry gas, and then you had to be able to do a gas laws problem. So just listing your variables will do enormous things for you. Listing your variables is tremendously useful here. So if you look at the problem, 750 milliliters of gas is collected over water at 38 degrees Celsius. Right there you have your initial volume, 750 milliliters. You have your initial temperature, 38 Celsius. Now, of course, we have to convert that, so that becomes 311 Kelvin. Pressure on the day of collection is 762 torr. Is that your initial pressure? You have to subtract out the water vapor pressure at that temperature. So what you're going to have is that P1 is, well, hold on. P total equals the pressure of your gas plus the pressure of the water. And so P total minus pressure of the water equals the pressure of your gas. That's a 762 minus 49.7 is equal to the pressure of your gas. Whoops. So what you get for an initial pressure is 712.3 torr. Okay? So now you've got all of your initial conditions. Now you have to look at your final conditions. This is where a lot of people missed something. It says at STP. Whoops, not STA, STP. I don't even know what STA is. So standard temperature is what? 0 Celsius. So T2 is 273 Kelvin. What's standard pressure? What is it? Yeah, 760 torr. 1 ATM. And I'm not putting in sig figs for that. When we're using STP, we kind of assume It's almost like a conversion factor. We wouldn't use that for our sig figs. Okay, and we're looking for our secondary volume. So we have P1 V1 over T1 equals P2 V2 over T2. Rearrange in whatever manner you like. We're solving for this. So So now we have our rearrangement completed. We're just plugging in numbers. Okay, so we've got everything plugged in here, and what we get for a raw answer is 617.0393679 milliliters for V2. Okay, so our sig fig answer, we have how many sig figs to work with? Ooh, how many sig figs do we have to work with? I messed something up. Hold up fingers. How many sig figs do you have to work with? Okay. 2, because of this original 38 Celsius. That went into our calculations. That was not used as a lookup. So that would be, what, 620 milliliters. Okay, so 620 milliliters would be our correct answer. And I marked that. I don't know if anybody had that. I marked that one wrong or not. But on my key, I used 3 sig figs, which is incorrect. Okay, let's look at, now this was definitely the most challenging of them because you had to do 2 different things. You had to do the subtraction of the water vapor pressure, and you had to do the gas loss stuff. So those are a little bit more challenging. You will have one like that. Let's see, wait a minute. Homework due Friday, conceptual test. And yeah, we'll do, it'll be like a big quiz, small test. You'll have one like this on that on Monday. Okay. Numbers 3 and 4, these are really just conversion problems. Can you convert and can you add and subtract? So what you have to know is that your total pressure is equal to the pressure of gas 1 plus the pressure of gas 2 plus the pressure of gas 3. So total pressure minus pressure of 1, minus pressure of 2 is equal to the pressure of 3. And then it's a matter of conversions, and I asked you specifically for the answer in torr. So you were given P total as 3.2 ATMs. You had to convert that. 760 torr is 1 ATM, so you get 2,432 torr. P2, because P1 was given to you in torr, so you didn't have to do any conversion. But we'll list it here.